Good morning again. Did you say that right? Yes! Hi, everyone. My name is Raquel Vélez. I am Rockbot on all of the things, except Instagram. If anybody knows who has the Rockbot account on Instagram, let's talk. OK. As Jameson said, I am the engineering manager of the services team at NPM. And we do lots of really cool stuff. We'll get into a little bit of it today. But first, I want to ask you all, fist to high five, right? How would you rate yourself as a JavaScript developer? Where like a fist is, you've just heard of JavaScript yesterday. It was kind of cool, but you know nothing. To you and Brendan Ike could have words. And you can totally do like a Fitbit sort of thing, like, yeah, OK, cool. And how many of you have ever written bad code? OK, excellent. Today we're going to talk about that. We're going to talk about bad code and what it is, how to get rid of it, when it's good, and when it can be kind of bad. So first, I want to kind of give you an overview of NPM. If you've never heard of it, NPM is a package manager for JavaScript. A lot of people think NPM stands for Node Package Manager, but it turns out that when the creator, Isaac Schluter, decided to create a package manager, he just picked 3 letters, and N, P, and M. They don't actually stand for anything. You could say that it has no prescribed meaning. And even then, you could say, like, it being a package manager for JavaScript is a little bit of a misnomer, because there's not just JavaScript in our registry. There's some CSS, there's some C++. Someone threw some Rust in there the other day. I think there's some Go. So really, it's just a package manager. But our #1 priority is to reduce friction, right? NPM is a tool for you. And when you're using your tools, you're using it to do something more important. So we want to get out of your way as much as possible. We want to be as fast and stable and reliable as possible. So with that, I'm happy to announce that NPM 5 was just released earlier this week. Yes! NPM 5 was over a year in the making. Our CLI team has been working really, really hard to make it fast, reliable, stable. And it's only going to get faster from here on out. And if you really like this Grease Lightning Wombat, I actually have a few stickers. I have a limited number of stickers, so you have to come say hi to me and like actually talk to me, and then I will give you one. So just keep that in mind. OK. So that said, we at NPM have written a lot of code, right? In fact, we've rewritten our code several times. And what I mean by that is, on our teams, like the website, we've rewritten it. We're on our 3rd rewrite right now. The registry API, we're on our 3rd rewrite right now. Our operations, we are constantly rewriting things because Terraform and Ansible are changing all the time. And so what that really means is we know bad code. We have seen it, we have played with it, we have gotten rid of it, all sorts of things. And so the big question is, of course, what is bad code? Now, when I was preparing for this talk, I took advantage of at NPM, every Thursday, we have an engineering all hands. And at those meetings, we kind of have like discussion topics or presentations or whatever. And I came in one day and I was like, hey, y'all, is there any like good things about bad code? And basically, they helped me write this talk. And by help me write this talk, I mean I let them talk, and then I just took everything they said and put it into slides. So what I'm going to show you today are code samples of real code from NPM. The good news is, most of it is not in production anymore. All right, so there are 3 major categories of bad code, right? There's functionality, maintainability, and readability. And the reason why I call these the 3 categories of bad code is because these are the 3 tenets of good code, right? So if you're missing one of these things, then chances are your code is maybe not the greatest it could be. So let's break each one down and kind of go in a little bit. So functionality. What is the point of functional code? It's basically to make sure that your code does what it says it's supposed to do, right? Like, that's the whole point of having code. You want it to do something. So in order for it to be functional, it's got to do stuff. All right, so when I think about bad code, kind of the first silly thing that I think of is like the supervillain code, right? Like this is the morally, ethically bad code. And good news, there's none of this in the NPM code base because we are good open source citizens and we do not do bad things. But there is one massive, huge code block, and you can ignore most of it except for the highlighted bits. But basically, let's say I'm a hacker and I make a package that does something evil, TM, then I get all their bank account numbers and get super duper rich and become a VC and create LinkedIn for cats. Like, this is morally bad, right? Like, this is just evil code. Fortunately, not exactly real evil code in our code base, but we are trying to deflect it. But there are people who write bad code, viruses and password sniffers and all sorts of things like that. So that's like bad code in one sense. And English is the worst language ever, so the word bad can mean lots of different things. But anyway, let's go back to functionally bad code. So at the core, functionally bad code doesn't do the thing that it's supposed to do, right? So here's a code example. This was in an integration test in our website. And the point of this code was to basically check to make sure that redirects are working. When you go to npmjs.com/package name, it doesn't actually go there. It goes to /package/package name, because that's just how things work. But a lot of people will do npmjs.com/package. Cool, let's make sure that there's a redirect that works. And you can actually see, okay, well, package redirect.js, that's fantastic, good solid name. And then we've got, it's actually a Selenium test, so it's going to the URL of /express, and then it's waiting till the page loads, and then checking to make sure that it reaches the package page called express. Cool, except why is the name of the test user with feature flag goes to the new org creation page? I don't know. This is not really doing what it says it's supposed to do. So this is functionally not great code. Let's talk about security risks, right? So with security risks, you're opening up yourself and your users to potentially malicious code, right? Like now you're opening it up to the bad actors who do the bad supervillain code. And so, example, this is we have a static page renderer in parts of our website. And okay, cool, no big deal. But what does it essentially do? It basically goes in and it says, all right, well, let's format this URL. And it's got two variables in it. One of them is system set. That's fine, we can trust our own system. But one of them is user set. And if there's one thing you need to remember about security is never trust the user. Ever, 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 right? So in a perfect world, someone would go to, say, /policies, and that would just take us to the new master/policies.md. And that's fine, that's where we want them to go. But let's say we have a bad actor and they want to go to /corporate secret /allthepasswords.md. And I'm not saying that that file exists in your code base, but if it did, this would be bad. So then there's always the case of only testing the happy path, right? When you're thinking, oh, well, this is the way that a user should do things. Well, again, never trust the user. And so if you neglect to handle error states, then you're actually neglecting very large swaths of your code. So, example, we have some old website code here that is for browsing packages by keyword. And okay, so what does it do? Well, it checks the logged in user and then puts together a list of all the different packages that they can see, and then it chunks it up, paginates it, and renders the view. Great, cool, fantastic. What's missing here? Nobody? Nobody. Bueller? Okay. So we're not catching any errors, right? And so, yeah, hypothetically it should be fine, but if something happens in the list function and it doesn't return something right, we're gonna send a 500 to the user. So that's it's just ripe for bugs, and we don't wanna do that. So this is functionally not optimal code. Okay, so that's functionality. Let's talk about maintainability. Now, the importance of maintainability is that we want to make sure that if our code needs to evolve, it can evolve, right? So something that's not maintainable means that in order to change the code, you're going to have to either completely gut it, or you're going to have to sit there for hours and hours trying to figure out what the heck is going on. Classic example, spaghetti code, right? what does this look like? This is lack of clear flow control. It's just kind of gnarly. And so what we have here is our validate and store code, which basically checks to make sure that a user is allowed to unpublish a package. Once upon a time, somebody unpublished a package and it did bad things. Won't say who. But we've fixed that now. But look at this code, right? Like you can see me highlighting the different then blocks in this promise chain, and it's just like, what is going on? It just keeps going on and on and on and on. And this is pretty spaghetti. It's not particularly maintainable because now you have to keep all this context, and it's just kind of gross. And then you have another instance of bad unmaintainable code, which is code with side effects. And so what happens here is you end up doing more than what's advertised. And you end up having, you have a function that's doing too much without telling anybody that it's doing too much. So for example, here we have some code that checks to make sure that you are authorized to publish a private package. And so you're checking the cache. OK, that's a great name for a function. But then somehow you could maybe create a package as part of creating this or checking the cache. Like, that's a little bit funky. If something were to go wrong in the creation of this package and we get that log later on, we're not going to immediately go to the check cache function. Right? We're going to go someplace else. We're going to not know where to go. This is side effects in your code, and that's really difficult to maintain. Ideally, you would have something like check cache and create package if necessary, but that's a really long, weird name. So keep that in mind, too. All right. Now for everybody's favorite section, readability. What's important about readability? You want to make sure that someone else, whether that's you, or maybe that's like a teammate, or maybe that's even just you in 6 months or 6 weeks or 6 minutes later because you went to the restroom and then had to come back and you're like, what did I do here? It's really important that your code is readable so that other people or you can look back on this code and continue to work on it. The most classic example of unreadable code to me is clever code, right? So when something is too clever, it makes it really, really difficult for anybody to get in on it. So here's a fun example. I mean, I know what it's like to be a clever dev, right? You're like, oh my God, I'm so brilliant. I have made this 100-line function into 10 lines. Look at me, I'm so smart. OK, yeah, great. Except what on earth is going on here? Like, really? Like, this is a ternary inside a ternary inside a ternary inside a ternary. And if you don't know what a ternary is, it's probably better off. Right? Like this is just, what is going on here? If it takes you more than 30 seconds to go, like if you need a pen and paper, I know we work on computers, but sometimes people need the old school pen plus paper to figure out what's going on. Maybe it's too clever. Or maybe you've got something that's just a little too long. We've seen these, right? We've seen the functions that go on forever and ever and ever. And this is a piece of code that's, it basically is trying to load everything we need in order to get to an org landing page. It's 150 lines long. This is not OK. The problem with this is that when you're writing code, I want you to think about writing code and reading code like eating a piece of pizza, right? If you have to consume the entire slice in one sitting, or I guess you don't really do slices here in Norway. If you do the whole pie, everybody here uses forks and knives, and we're barbarians. We use our hands in the US. But it's important to not have to eat the entire piece of pizza at one time. You should be able to eat it in little chunks. And so if you have this really massively long thing, you can't maintain the scope of it all in your head. It's just too much. It's not readable. And then finally, this is the really fun one. This is the one that everyone on Twitter and Medium and everything like to go in on. Style standards, right? And I'm talking about code style. And so let's take a look at a piece of code. We have a loudbot on our NPM Slack. This is the code behind the loudbot. So what's wrong with this code? Well, let's see. first of all, we're using tabs. Like, what is that? And not only are they tabs, but they're four-space tabs. And then, the weird new line curly brace, like, what is this, C++? And then semicolons at the, and whoa, hold up, and hanging semicolons? Yeah, no. No. There is nothing wrong with this code. In fact, that code is functional, maintainable, and readable all at once. It's really important to remember that style is personal. It's so common to see people screaming on Twitter like, oh, semicolons, no semicolons, tabs, spaces, Famimax, whatever. Like, it doesn't really matter. Style is personal. It'd be the equivalent of me coming in and being like, y'all, black is so last year. You need to just, change all your clothes, because that's just gross. Like, that's just rude. That's rude. Don't do that. All right, so here's my recommendation, instead of having to deal with all this style stuff. Use a linter and get over it. For those of you who are wondering what a linter is, it's basically a script that will automatically change the style of your code. You can have it do two options. You can have it warn you and say, hey, we agreed there'd be no semicolons in this code base. You've got a semicolon. Maybe you should get rid of it. Or you can have it automatically do it, and just like when you press save, it just goes, by semicolon. This is how I prefer. I actually prefer the automated way, because personally, I don't want anybody to tell me what to do. I just want the robot to just do it for me. Right? Okay, cool. So we've talked about lots of different ways of, different types of bad code. So now let's talk about how to minimize this bad code. So in order to minimize it, first we need to be able to identify it. We've talked about different categories, but now what are the signs that we see that are like, okay, this is smelly, gross code? So lots of different options. First of all, if there are many branching paths, right? If you've got lots of if-then-else trees, if you've got a bunch of ternaries, if you've got a bunch of .thens, whatever, maybe that's like you have too many branches, too many paths, that's smelly. If you have context-dependent understanding, like if somebody needs a PhD just to understand how to do whatever it is in your code, like that's not particularly helpful. Yes, there is some inherent knowledge, but think about it from a new developer perspective, like somebody who's just joining your team. If they need to spend 6 months just trying to understand your code base before they can contribute to it, that's a bad code smell. And then also weird/long variable names, right? Like so in the example that I gave before, check cache and create package if necessary. Like yes, that's nice in an understandable name, but it's really long. Maybe you're doing too much. Classic works on my machine, right? Like if it works on your machine, great, I'm proud of you. You can have a cookie, but if it doesn't work on anybody else's, that's a code smell. And it's really classic. People love to like make their own stuff, right? Like the not invented here. Like, oh, yeah, it'd be really great. I could totally create a new logger instead of just using console.log. It would be a package that just, I don't know, whatever people like to do and invent on their own. But at NPM, we really love the idea of many small modules, right? Like that's our ethos. But think of it this way. You could spend your time writing all of these different modules for yourself, brand new, whatever. Or you can go onto NPM Search, which actually works now, and you can, yes! And you can try to find another module that already does the thing that you want. And the beauty of this is, if it already has really good tests, and you've got a lot of people downloading it, then those are edge cases that you don't have to worry about finding later. And it means that you could just focus on getting your actual work done. And if they don't have everything that you want, you can just put in a pull request, because yay, open source. Okay. And finally, the stinkiest cheese of all the smells. If you know it's going to break, it's probably going to break, and it's probably not very good code. Okay. So now that we have identified all of the smells, let's find a way. Let's talk about how to clean them. And so one of the biggest things that we like to do at NPM is pair programming. And some companies, they do like the full 8-hour pair programming, Gesundheit. that's really asking a lot. At NPM, we try to do just like an hour-long sort of pair programming session. And what's really great about this is you have another set of eyes, especially when you've been working on the same piece of code for days or weeks. You miss stuff. And having a fresh pair of eyes take a look at it, they can ask questions like, that's a really long, weird variable name. Are you sure you're not doing too much in that function or something? And so this is really, really helpful. I also like to encourage people to commit early and often, and to make sure that your tests pass after every single commit. The benefit of this is that you can go through and you can say, all right, here's my commit, I've done this thing, and you can see, oh, wow, I just added like 75 different lines to this one function. Maybe I should cut that down. And so being able to keep track of your commits is really useful. That said, write tests. I know writing tests is a huge pain in the butt. I get it. But it's really, really helpful to automate away somebody else checking your code to make sure that it's at least functional, right? Like, tests aren't going to automatically check if it's readable or maintainable, but they will check to make sure that it's functional. And anything that you can get computers to do instead of a human, I think, is always a good thing. And honestly, if you're writing a test and it's too hard to write the test, maybe your code is a little too complex. So that's a good way to kind of check to make sure that it is actually maintainable. Like I said before, use a linter. At NPM, we like to use standard. I think it's really important that folks really spend the time that they would spend arguing about style to just come to a decision and just keep going and working on things. It just doesn't make any sense to constantly be going through and being like, oh, well, I hate your semicolons. Well, I hate your semicolon. Or I don't know. OK. Code reviews, finally. Last but not least, code reviews. At NPM, we try really hard to ensure that nobody merges their own code by themselves. And the reason for this is to ensure accountability across the team, right? So if you're the only one who knows how the code works and you push it to production and then it breaks and then you go on vacation, like everyone else is kind of stuck. So having good code reviews is really essential to making sure that your code is doing what it needs to do. Now, when I do a code review, I take forever, and there's a reason for this. I have a 3-step process that I want to share with you. So when I'm looking at a pull request, I do a full holistic overview, right? Like I'll take a look at the description in the pull request and make sure that what they say the code is going to do actually matches what the code does. So that's the functional bit. And then I go commit by commit, and I make sure that each commit is maintainable in each and every single section. That way I can be like, OK, yes, this makes sense. I can see where this is going. And then I go line by line in each commit. And that's to make sure that it stays readable. I make sure that there are no spelling errors, and I make sure that everything's kind of going exactly the way it should. So yes, it takes me forever to finish a code review, but at the end, I feel confident when it goes out to production that it's not going to totally break everything. OK. So all of that said, when is bad code good? Right? Now, this is the crux of this talk, right? Because it's really fun to make fun of bad code, but did you know it could be good too? OK. CJ Silverio is our CTO, and she actually spoke here at Web Rebels a couple years ago, and she said this wonderful thing in our chat a few months ago about this. And she said, the beauty and horror of code is you get to see how other people think. And I think this is so beautiful, right? That through someone else's code, we can get some insight into their brains. Like, that's just such a huge humanitarian sort of thing. Like, oh my God, I see into your brain, into your soul through your code. Like, so cool. But honestly, when we're writing bad code, a lot of us don't always know that it's bad code at the time. Right? Like, whether you're just starting out or even just playing around with a new concept, you don't know what's bad until later when you go back and you go, wait a minute, there's a bug here. Oh, shoot, I have no idea where this came from. Let me refactor, right? That's a great opportunity because it's a learning opportunity. And so I think when we write bad code, it's a learning opportunity for us to improve ourselves. And when we write bad code, it's practice, right? It's an opportunity for your code to give you the feedback so that you can be better. So if you're going back and refactoring, you've now learned a thing about how to ensure that you don't write that kind of bad code again. those of us who are a little bit more advanced in our careers, how many of you have ever just written code because it's good enough? You're like, all right, you know what? I just got to get this done, so whatever. I just need to get it good enough. Or maybe it's like, maybe it's exploratory code. Maybe you're playing with a new framework for the first time, and you're like, you know what? I don't need variables. Everything can be, a global. It's totally fine. Whatever, I just want to play around with this new thing. And that's great. That's totally fine. I think it's important to remember, perfect is the enemy of the good, right? Okay. And then for those of you who work on product, or maybe even work on client work, but particularly you product folks, you're with me on this. Sometimes you know you have to ship. It's that last minute moment, and you're like, oh my God, I have to ship this, and I feel really dirty shipping this code. This is gross. But after we ship this, I'm going to have time to clean this up. So I'm going to purposely make it really ugly so that when I come back to it in a little while, I'll go, oh, good God, this is the most disgusting code I've ever seen. And it's like a signal to refactor. And then you feel really good because you're cleaning it all up. I don't know about you, but I've got devs on my team who are just like, yes, this is the greatest thing ever. So you write it to throw it away on purpose. And so that's fine. Sometimes you just got to ship. And then finally, I think it's important to remind people that bad code is more than just code. It's really common for folks to create these really great interfaces, and they write these tests, but underneath it all, it's really ugly. I don't know if you've ever looked at the CLI code base from before NPM 5, and even still in NPM 5, there are going to be some trolls hidden under the bridges. But it can be kind of scary in there. But no, most people don't really notice. They don't really care, because as long as it works on the CLI, as long as I go npm install and it does the thing I need it to, it's fine. But it's important to actually run the code before you judge things. So I want to show you my very first JavaScript that I've ever written ever. And this was probably 8 years ago. And so I actually submitted this for my first web dev job ever. I was like, oh, you know what? I want to be a JavaScript developer. How hard can this be? I'm going to do something cool. And so this was my very first code, for my very first JavaScript code. I wrote C++ and Python before that, and I got rejected. I was totally rejected. Nobody wanted to hire me. And so let's take a look at why, right? So yeah, okay, there's some Python-y type syntax, and I totally did the new line C++y thing. And to be fair, there's some really too clever variable names, like what is VIP? I don't even remember. And you definitely need to have some sort of advanced understanding to understand what is even going on here. But what happens when you actually run this code? What you'll see here is a fully articulated three-dimensional hand. I was a roboticist before I came into web dev. And so I know some of you are looking at it and go, ow, 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 right? Because it's like, that is not human. That is not how a hand works. But why are you saying ow? It's because it's close enough to reality that you're starting to self-identify with it. And so, I'm not bitter or anything that they rejected me for this code. I mean, honestly, I work at NPM now, so I think I turned out okay. But come on, if they had actually run the code, they probably would have seen some promise. And all of this to say, bad code is part of our origin stories, right? Every single one of us has a story about the bad code that they've written. It's just part of who we are. We've all done it. And in fact, when we sat down and talked about bad code at NPM, we're all sitting there with smiles and laughing, and we're just cracking up, because it's like, oh man, there was this one time I wrote this really bad code, and it did this really awful thing. Ha ha ha, you're right? And every single one of us does this all the time. And honestly, every time you change languages, you kind of fall into this whole thing again anyway, right? Of course, it varies with experience. Those of us who have done more languages, we tend to figure out the code smells ahead of time, and it's just syntax. But I do want to remind everybody that just like when you're learning a new foreign language, when you're learning a new coding language, you write with accents, right? So you have this whole I had a Pythonista, C++-ish type accent when I was writing my first JavaScript. We all do it. And so that's why I think code style in particular is a silly code smell. Anyway, so we've talked about what is bad code, how to fix it, what's good about bad code. But now let's talk about what's wrong with bad code. And ultimately, it's that we mock bad code. We make fun of it. And that's OK if it's our own code. But when we make fun of other people's code, then things start to get a little bit weird, right? It's become this weird institutionalized behavior, like some sort of rite of passage of, oh, well, that person made fun of my code on Twitter, so I'm going to find some other rando and be like, ha, 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 that's a terrible looking code. You should feel bad for yourself. But what happens? What happens is that new people come in and they're afraid. They're genuinely scared to publish anything publicly because they're afraid that they're going to get mocked too. And what kind of environment is that we're creating for each other? Like, that's no fun. You shouldn't have to be weeded out for being too sensitive. Like, it's just code, y'all. And we create this super unhealthy attachment to our code. You end up having people who are either extremely stubborn about their code, like, oh, well, I wrote that code, and you will not touch it. It is mine, and this is very important, and it cannot be removed from production ever because I wrote it, right? Or you have this other side of things where people are like, oh my God, they just have this self-feeling, I don't know how to call it, they self-identify with their code, and so they're like, oh my God, you made fun of my code. You're making fun of me. Oh, my code is bad, and therefore I am bad too, right? And it becomes a source of shame, like, yeah, I wrote some bad code, and I feel really bad about it now. And it's y'all, code is ultimately zeros and ones. It's a thing for the computers. It's not about us at all. That said, code is an act of communication, right? It's how we talk to each other so that we humans control the machines. Don't believe anything anybody else ever tells you. The machines will never be taking over. I promise you this. I've seen too many robots fall off the stage. So code is how we communicate with each other to make sure that the robot underlings do exactly what we want them to. And like any act of communication, writing good code is hard. It's really hard. It takes years and years of practice. I've been coding for over 10 years, and I'm still learning new things. Like, I come to conferences because I want to learn how to code even better, right? And hopefully every single one of you has been learning something new at this conference. I know I have. So ultimately, please accept the bad code so that you can become great developers. That's how this needs to work. So to close, I want to share with you a blog post that I wrote at the end of 2014. And it's pretty short, so I'm just going to read it verbatim. Your code is not a reflection of you. It isn't a reflection of your beliefs, your upbringing, or your ability to be a good person. Your code is, however, a reflection of your thinking process at the time that you wrote it. Given our innate ability to change our minds, consider other viewpoints, and play with new ideas, why do we hold our code so dear? Your code can change, your code will change, and your code must change if it's ever going to get better. So stop marrying your code. The sooner you accept this, the happier you will be, and the better programmer you will become. I promise. Thank you so much.
So since I'm talking to you, do I get a sticker, technically? Like so. That's how you will also get your own sticker. Great job. That was fantastic.
Yay!
I want to read some of the Twitter feedback. Really enjoying the Beauty of Bad Code talk by Rockbot. So much truth. Another one was, I would pair with these cuddly wombats when you had the pair programming.
Yeah, I know. The wombats are the cutest, aren't they?
Do you have a designer whose job it is to full-time crank out wombats?
It's a freelance, he's a freelancer, but it's John Q, ITSJONQ on Twitter. Send them a shout out. Be like, I love your wombats. Yeah, a lot of people often ask, like, why is it a wombat? So I'm just going to answer that question right now. If you take the NPM logo, right, and you turn it upside down, it's WDU, which obviously means Wombat Developer Union. Right? That's why. It's not a bear, it's a wombat. It's an Australian marsupial and basically the cutest thing ever. The end. Okay.
Okay. Another question from the audience was, how do you solve the code review that is friendly and true problem? So I think that means sometimes people can feel very criticized or feel like the criticism in code reviews is like personal or harsh, and like they want to get criticism to make the code better, but also how do you not feel bad?
Right. Okay. So first of all, the code is just code. It has nothing to do with you personally. Now that said, as a code reviewer, maybe don't say, wow, this sucks, so do you. But what you can do is, so what I like to do is here's a management tip, right? I was a coder forever. I don't get to code very much anymore because I'm a manager now. But when I'm giving personal reviews, like status reviews and things like that, what I'll often say is, hey, here's what you're doing really well. And then I'll say, this would be here's a challenge for you, right? As opposed to, here's where you suck, right? Instead it'd be something like, hey, have you considered X or Y? Something like, hey, this code, this function is super, super long. It's really difficult for me to parse it all in one go. Have you considered maybe breaking it up into multiple functions, right? And so it's a lot about how you as a reviewer respond to the code review. And that way, the person who's receiving the code review will go, oh, this person genuinely wants to help me be better. And not just, oh, this person thinks I'm awful. And so I think, yes, on some level, you as the reviewee needs to not take it personally, but there's also so much that we as reviewers can do to help kind of create an environment of friendliness and constructive criticism.
Yeah. Here's a challenge. Use more than one letter for your variable names.
Yes.
I challenge you.
I challenge
you. Can you do it?
I mean, y'all saw my code. I was just I look back at that and I go, oh.
Another question from the audience was, what was the worst code you saw during code review in 2017, and what did your team learn from it? The worst is you have to come up with the right answer right now, but I can amend that to just bad. I don't know. Or an instructive example, maybe.
Oh gosh. I mean, here's the thing, right? With good pair programming and good code reviews, you stop the bad code from ever making it to production, hopefully, hypothetically, ideally. But probably something I wrote because I'm a manager now. Sadly, I think it's probably something I wrote. I couldn't give you an exact example because to me, bad code is, like I said, it's just a part of the process. So as soon as the bad code exists and then goes away because we fixed it, I forget about it. I don't hold it in my head. So I'm sorry, I can't answer that question.
The question I had was, how does bad code written by experienced developers differ from bad code written by newer developers?
Ooh.
Because everyone writes bad code.
Yeah. I think newer devs just don't know what they're doing. So they are just like, okay, well, I'm trying something new. And it'll be a little bit more simple type stuff, like the functions are too long, or the variable names are terrible, or the you just see stuff and you're like, oh, you're brand new to this. It's adorable. But then with more senior devs, you start to see things like, you're being real clever here, aren't you? Yeah, you are. Maybe you should consider other folks. I think one of the big things that I see is that more experienced devs tend to think about their code just for themselves. And new devs do too, but more the experienced devs, they don't always consider who's going to come in and look at that code again later.
Okay.
And so it can be a little bit less readable. It'll be functional, it'll be beautiful, but it'll be really hard for a new person to parse.
So kind of like with the accent thing, it's like they have their own dialect that they're very fluent in, and no one else
Absolutely.
is
It's like,
as fluent in.
it's like hanging out as a freshman, or sorry, I'm using American lingo. If you're a first-year university student and you walk into like the professor lounge and they're all talking about something super, super nerdy, and you're just like, I don't know what half those words mean yet. I think it's kind of one of those things.
Sure. Cool. That makes sense. Well, thank you so much for your talk.
All
It was
right.
fantastic.
Yay!
And
Don't lose
again,
that.
come talk to her for a sticker.